Okay, this exercise is just given 2 examples as your warm-up. There's no great new information. Just remember from the earlier exercise in this chapter that if I'm talking about the size of a set A, it's denoted as the size, like with these 2 signs, very similar to the modulus function, okay? So that's the size of A. Today we're just going to work through problems using 2 sets. There's one with 3 sets, and you need to do questions 1 and question 7. Also, you remember that Venn diagrams are awesome. The other thing I will say is that there is one video for this whole exercise, and that's this one. So I'm going to do the examples. If you're confident just reading it, you can skip the rest of this video and just read what I've done. Or let's do this together. All right, so we'll be using Venn diagrams, as I said, to do this. So for our first one, I'm going to have my superset, or my set of everything. In here we'll go xi, okay, and what have we got? There's 280 students. So that means the size of xi is equal to 280. And of these students, 150 travel by train. And okay, so 280 students travel to school by either train or tram or both. Okay, so there's no one who doesn't. So let's call this one. Oh, they both start with T. That's annoying. So we'll call this train. And this set here will be tram. So 150 travel by train and 60 by both. So I always start off with the, I'll just put a note here for those who read, start with intersect, because then it's easy to work out. Because train has to have 150 in total. So 60, that means there's 90 there. Oh, I don't know, I put the 1. But also in this case, we know that there is 280 in total. So the students on tram and not train make up the rest of the 280, so that would be 130. Okay, so that's our Venn diagram, part A. And what do they want? I'm just going to work over here for parts B and C so I can see the question. B, how many students travel by tram? Well, I probably didn't even need to do the Venn diagram for that, but anyhow, we have done that's 190. Okay, so the size of tram is, should say A and B, but anyhow, equals 60 plus 130 equals 190. The next part is train, but not tram. That's 90. So, but the way to write that is, so from now on, I'm actually going to say over here, let me just say train is equal to A and tram is equal to the set B, all the students who write on that. So look, we can get rid of this and say that's B and that's A. And I can just write this over here. So that's the size of B. Okay. So this one here is, so we're looking at the size of A intersect, not tram. So intersect, not tram. So that is equal to just this 90 here. All right. And part 3 is how many students go on just one of these transports. So how would I write that? So this is, it's called an exclusive OR. So this is when you say OR in English, this is actually what you're thinking of. So we're thinking of A intersect not B. So what's the size of that? Union with the intersect, not A intersect B. Okay, so this first one is obviously equal to 90, and the second one is 130. So that equals in total 220. Or you could have said 280 minus 60. Either way, that would have worked. Okay. There might be a neater way to write out this exclusive OR as well. There is a symbol for it. We won't do it today, but all right. Anyhow, so let's do this. Let's do the last question. All right. So now we've got an athletics team. We've got 18 members. Each member competes in at least one of 3 events: sprints, jumps, and hurdles. Every hurdler also jumps or sprints. The following additional information is available. So let's draw the Venn diagram before I confuse myself. So I've got my square, and we've got 3 things going on here. Now let's ink to shape. And that's better. Let's get rid of that. So this is S, sprints, jumps, and hurdles. And so what was I saying before? Every member competes in at least one of the 3 events. Every hurdler also jumps. Oh, they either jump or sprint. It's not both. Okay, so but that also means that this space here will be empty. But that's another story. Okay, so S in total is going to be 11. That's not going to help me at the moment. And J in total will be 10. So J intersect with not H and not J. So that's just this one here. That's 5. And not J, not H intersect with S. That's also 5. So the people who just sprint and just jump, there's 5 of them. And the people who jump but not hurdle is 7. So this is jump but not hurdle. In total that's 7. So we've got 5 there already, so that has to be a 2. And question, how many were there in total? 18. So so at the moment I have 12. Well, jump and not hurdle. Yep. Well, I can think about this then. So how many people sprint is it? Okay, so we can do this in total. So how many people sprint in total? So this is the 2 for not there. So the people who sprint in total is 11. So these 2 is 7. So it has to be 4 in total for this one and this one. And the people who jump in total is 10. So there has to be 3 in total here. Does it say how many people do hurdles? It doesn't. Let me just have a go at trying to use some algebra. I'm going to call this X and Y, Z, and whatever this is here, and call it W, I know that that's going to be equal to 0. All right, so it doesn't tell me anything about how many people actually hurdle. So all I know is that X plus Y needs to equal 4. Is that right? Because we need to have 4 more. And Y plus Z needs to equal 3. So if I made Z 3, then X would be 4. Is there anything about the intersection of J and S? Oh, and one, oh yes, sorry, there's one more too. So it has to be 18 in total. So I also know that X plus Y plus Z has to equal 18, and I have 12, so it equals 6. Is that right? Yes. So so if X plus Y equals 4, I name these number these equations 1, 2, and 3. So if X plus Y has to equal 4, then Z has to equal 2. All right, so now I can, looks like a 2 already. And so Z equals 2, and Y plus Z has to, so Y has to equal 1, because there has to be 3, so that gives me 2, 7, 9, 10 people jumping, and that means that what did I just make? Y was 1, so X has to be 3. So 3, 4, 6, 11. Okay, and there we go. So that's the total amount of the 18 jumpers in there. So let's do part B. So the size of H has to equal 3 plus 1 plus 2 is 6. And the size of S, the size of everybody who does everything is 1. There's only one person. And the size of S union J should be 18, I think. Because there's no one, yeah, so everything's in S and J. Yep. So S union J is equal to 18. And the last one, so the intersection of S and J, didn't we do that? So wasn't that one of the things they gave us 2? Well, how did I get that at the start? Forget now. But they'll equal 2, intersection of S union J union not H equals 2. And I'm just going to double check. How did I get that 2 at the start? I knew that this was 5. The J, this one here was 5. And I knew that this one was also 5. And I knew that jumps not hurdles, so that had to be 2. That's already knew where it was 2. So the intersection of jumps and not hurdles, okay, that's why I knew that was 2 already. Okay, so that's all of it. So you can see that I thought, following on from the first one, I'd be able to just do this by reading the initial things, but it does start to get quite complicated, and I did need to use some algebra here in the end, because the way that we put these 6 here could have gone a number of ways. So yeah, it's good to make sure that I got it right. Okay,